enlighten some of us, even though we'll probably be grading all spring break. But anyways, just a side note. If anyone didn't notice, today was the 45th day 45th day census date. So you may see in the next couple of days your class is getting smaller because anyone who hasn't been participating according to a faculty member's uh, attendance policy will be withdrawn today. So just to highlight, I don't think anyone in here has that concern, especially in this class, because you're all amazing students. All right, so let's go ahead and get started. So last time what we did was an introduction to sensations and perceptions. And the thing that I'm trying to drive home is this notion that the objective world, as we would say it, the world that exists is not the world we actually perceive and exist with. So I mentioned the idea of priming and what it can tell us when we see a stimulus. We've mentioned how we have natural blind spots that our perceptions fill in, and how mood can influence our perception of the world. And we talked a little bit about culture. Okay. What I'd like to do is get into one of the areas of psychology that is known as psychophysics. Okay. When we look at psychology as a field, one of the things that makes it so complex is that measurement can change, and then so does the theory. And so, because we're not like a lot of fields where you're just measuring the height of a plant, or you're looking at the different measurable sequences of DNA or RNA, we're measuring human experience. And so the precision, we're getting better and better. And sometimes, like I said in the beginning of the semester, when I introduced some of the myths about psychology, and I mentioned some studies that then went and became big industries like the learning styles crap and all those things. But when measurement gets finer and finer, we find that some of those things don't actually work out. But there is an area of psychology where we do have some pretty precise things that we actually can call laws, because they tend to go across culture, they go across people, they go across gender, and that is the measurement of psychophysics. And basically, what psychophysics is the measurement at what threshold do we detect stimuli. Okay, so for example, we'll get into the wavelengths that we can detect as human people, human species versus other species here in a little while when we get to light. But there are some definitions I just want to go over. So the first one is absolute threshold. Okay, this is the minimum amount of stimuli that we can detect. Okay, so this is what we can detect most of the time. Okay, noise is anything in the environment that interferes with our ability to um, 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 see the minimum threshold or the absolute threshold of what we can see. An example of this is that technically, if we had a 30-mile vacuum that sucked out all of the particles in the air, sucked out all of the light, all of those things, and it was 30 miles long, technically, as a human being, we could see one candlelight flicker at the end of that 30-mile vacuum. That's our visual acuity, is about 30 miles for one um, um, candle flicker. Okay, the reason why we can't see it, why we can't see the absolute threshold, is because of all the noise between between that and that stimuli. Whoops, where am I going? Go this way. What the heck is happening? Hold on just a second. We were up here. Okay. And then last week we did have a conversation about subliminal perception, which also can interfere with the minimum amount of stimuli that we detect because we might be filtering out stimuli that we're subliminally not expecting. So we want to get the perception that we need to have. And so a lot of times we can filter out stimuli. Okay. Probably the best example of this is hearing. While we're driving, and I may have mentioned this in this class before, when we're driving, we actually are hearing a lot of noise. Okay. Now, modern cars are getting better and better, but if anyone has ever known someone who had driven long haul trucking for their whole life, you'll probably notice that they probably have a hearing aid and they have problem hearing. Okay. That's because technically, when we're driving, the decibels are pounding on our ears from the road noise, the cars next to us, the wind coming through the vehicle or across the vehicle, but we don't perceive it because we filter that out so that we could focus on driving and knowing what other important sounds like a honking horn or a police siren or something else, which is more important to us getting from point A to point B. Okay. And this is kind of the idea behind subliminal perception. So sometimes there is noise in the environment that prevents us from seeing and hearing everything and experiencing everything. Oh my gosh, why are you doing this? But we also have perceptual expectations that make it so stimulus in the environment may convert itself into what we expect. Okay. Now, those are all detecting stimuli at some point. Okay. The what's called the different threshold is when we can discriminate from one stimuli 50% of the time. So what this means is, so when can I notice a change in the shade of red? When can I start to notice the difference between red and green or two tones of noises? Okay. And this is what's known as differences threshold, right? And as I said, this is one area of psychology where we do actually have laws that determine these things. For example, Weber's law. I think I have a, let me hold on just a second. Let me get out of here. I want to stop sharing for just a minute. I want to get into, let me get down here. Where are you? Almost there, I think. Okay, there's that. Okay, well, this is this one. So when I was talking about the minimum level of stimuli that we can detect, here is the example. So let me just blow this up a little bit. So this is first going back to the minimal amount. So this is for taste. We can taste about 1 teaspoon of sugar in every 2 gallons of water. That's the minimum threshold or absolute threshold. When our smell is pretty acute, we can smell 1 drop of perfume diffused into an entire volume of 6 rooms. Those are standard rooms, so it would be if you want to think about this, as if you've been in a classroom, it's about 6 classrooms. Touch, we can feel a fly's wing falling on our cheek from a distance of about 0.04 inches. Hearing, the tick of a clock at about 20 feet under quiet conditions. Okay. And our vision, just like I mentioned earlier, we can see a candle about 30 miles away in a dark, very clear, uncontaminated night. So those are our minimum thresholds. And again, when we test this across cultures, across people, across everything, it kind of holds to these kind of standards. Okay. Um, there was a did want to see if it gave the example, this one. Let me see. No, that's just that one. So let me get out of here and I'll go back to that other one. And I want to get back to Weber's law. So what Weber wanted to know is, in order to know the difference in a stimuli, is it the amount or what is it? Okay, and this is the going to be this slide right here. No, no, oh, I just went in the wrong one. Sorry. Let me catch up with you guys. All right, Weber's law. Okay, so this is one of the laws that we do know is again something that goes across gender, ethnicity, culture, is what Weber found, and I'll just put it in simple terms, is the difference between two similar stimuli. So weight, taste in this bitterness, sourness, pressure on the skin is not the amount, but the percentage. Okay. And this is important because I kind of want you to think about this in kind of a weight loss type of situation. When can a person be able to tell that they've lost weight? And therefore, that should help kind of set goals. Okay. But let's say in order to sense a change in weight, you have to have a 5% change. Okay. So let's take a 100-pound person. So, in order for this person to feel loss in weight, they'd have to lose 5%. Okay. And so 5% of 100 is 5 pounds. Okay. Now, let's say this person has a friend that has a weight loss, that is doing weight loss with them. But let's say they weigh 300 pounds. Okay. 5% of 300 is 15. pounds. So for this person to feel success in weight loss, to actually feel it, why does that keep doing that? They would need to lose 15 pounds. So if they both have the goal to lose 5 pounds, the friend that's 100 pounds is going to feel really good about themselves because they'll notice that they've lost that weight. But their 300-pound friend isn't going to feel it at all. Okay. Now, this is why it's when people become larger, they don't notice weight gain as quickly as less heavy people. But this is also, I'll tell you, one of the ways that this was used is I worked in for a little while, I kind of substituted for a friend at a camp for teens who had anorexia. Okay. And so I first want to go back to my first statement. One, this is why we feel like we gain weight faster the more weight we have on our body. The reason is we're not feeling that weight gain at the same rate we were when we were at a lighter weight. Okay. If you're looking at this and going, well, what should my goal be? Well, if you're 300 pounds, in order to fill that, you have to lose 15 pounds. You might want to use a different measurement, such as the waist size or something like that, so that you can see the success, okay? Because you're not going to feel it for a while, all right? Compared to the 100-pound person. Going back to the anorexia example, what they did at this weight clinic or at this camp, it was a summer camp, it was a beautiful place, it was back east, is what they would do is, so Weber's law says 5%, and so they would get the person to gain up to about 103. To about 103, so about 2 pounds under the Weber's law. And then they would leave them at 103 for about a week. And then they would do 5% of 103. So you probably go all the way up to 5%. So the next weight they would take them up to would be 108. And then stabilize them for about a week or a half a week. And then they would then go up again. Now, this is a kind of the scientific part of it. It doesn't take care of the psychology part of bulimia or anorexia. But this is one way to kind of make it so weight is gained, but then it's not being triggered by the person who will then go through the anorexic or bulimia illness or process. Okay. So they do this while they're working on all of the other issues that are associated with the disorder. But this is one way that Weber's law has been used to help people who, for example, have an eating disorder. Okay. So Weber's law, it's important to note it's a percentage, it's not an amount. And so something to kind of keep in mind while if you're trying to change something about the way you are. So now I mentioned perception, and we talked about subliminal perception and stuff like this. What I want to do next is show how amazing our perception system is, about how quickly we can adapt to an almost completely different world. And it's done through what's called a perception or an inverted vision task. And I just want you to notice how quickly we adapt, even if our perceptions are changed completely. Okay, so let's watch this video, and I hope it'll be understandable. Anyways.
For another clue to the brain's remarkable adaptability, consider Susanna Fines, a London art student who has agreed to undertake a curious experiment.
Now then, Susanna, if I could have a look at these most unusual spectacles on you.
For one whole week, she will see the world upside down, inverting once again what the lens in the eye does anyway. Our brains correct for this inversion. Now hers will be forced to make yet another correction. Will she be able to make sense of an upside-down world?
Car's going upside down. God, that's really weird. Because I'm sure I'm holding the cup up.
At home, an hour later, the world is still bewildering.
Got it. It's funny, I just suddenly do it. Lost it again. Oh dear, do that. It's extraordinary.
On the third day, Susanna tries to write her name without looking.
No, it's rather difficult to know which end to start. What's that? Oh no, it's getting worse and worse. I can read that end, but not the rest of it. Shall I try and write it now, so that I can read it all?
Once she looks, she's able to invert the letters completely. Clearly, in 3 days, she's made progress, integrating upside-down seeing with upside-down moving.
There, now I can read that quite easily.
On Susanna's final day, she tries to draw. With a week's practice, she can now sign her name to the drawing right side up while looking. The seeing part of Susanna's very flexible brain has somehow matched the unchanged world to her altered vision.
Right. Well, I've been wearing them for a week, and I'm going to take them off and try and walk across the room. I don't think I dare do it. It's so terrifying. Ah! Oh, goodness. Ah, it's really extraordinary. Oh, that was funny. That is just so incredible. Just to feel everything all around me again. Amazing.
And now, Susanna Fine's brain has managed yet another inversion of the image.
It's an extraordinary feeling.
And this time, it's taken just 1 hour.
And then suddenly I just feel as though nothing ever happened. If you look round, everything seems completely normal again.
This basic pathway of vision is therefore flexible, plastic. It's ready to help us adapt to a world that changes.
All right. So kind of the purpose behind that, and because as we get into vision and we get into auditory systems and whatnot, we will know that they're not perfect. That really our perceptual system is really going to be the star in making everything make sense to us and be so clear. I'll just give one more example of vision and how our brain makes it so we see what it thinks we should see. Okay. I already mentioned that if the image hitting on the back of our eye was a one-to-one association with what we see, we'd already have two dark spots in our eyes. But also, if you look at the image that is projected on the back of the eye, one, it's upside down. And then as the neural tracks go to the back of the brain, it flips it right side. So we see things from bottom up instead of up down. The other thing is I used to have goggles that I would take classes and have you put them on in order to see what the image on the back of the eye looks like. But I'll give a verbal description right now is if you've ever been in a heavy, heavy rain, when you're driving your car and your windshield wipers are not working. Okay. The image you're seeing with the rain and everything on the windshield is actually the image that is being projected on the back of your eye. But through the process of perception, the brain cleans up that image, it inverts it, and takes care of your blind spot. Okay. So if you kind of think of that, it's kind of cool. One of the things that has been debated in sensations and perceptions is, do we see the whole or the sum of the parts? And this is actually a German type of psychology. And I'll tell you, if you're really interested in psychology and you really like Native American psychology, I would encourage you to look into Gestalt psychology, because it's more about the wholeness instead of the sum of the parts. And indeed, a lot of German scientists and scholars actually invite Native American people from the United States over all the time to give lectures and talks. I believe one of our writing literature professors, Dr. Cassador, is invited to Germany almost every summer. A lot of summers since I've worked here, where they come over and they want to know what his views and stuff on different topics are, because there's such a more connection between the way German scientists and German scholars see things and Native American scholars. So it's kind of an interesting kind of thing where Gestalt psychology is largely talked about here in the United States is with sensations and perceptions, because it kind of shows us how we kind of group things in order to make sense of them. Okay. So, for example, if I were to, let's actually do this, put in the chat, do you see a young lady, an old lady, or both? Gina says both. Vanessa says both. There's a lot of boths in here. Cool. Young, both. Young. Okay. If you remember that video, again, looking at things as a whole instead of two separate things, some of us see both, some of us, I always had the hardest time seeing the old lady. As I get older, I see her more often. But what is going on in this picture? If you remember at the beginning, we had that dolphin versus two humans holding each other kind of image. This is very similar to this. Is what we want to do is make complete sense of this image, okay, as a whole, not just parts of it. So what do we use? We use experience. Okay. So before having this class, if for the last, let's say 2 weeks, I had you kind of just notch down the number of young people you interacted with and the number of older people you interacted with. Okay. Not always, but most of the time, if you interacted with mostly younger people, you would be likely to see the younger female. If, on the other hand, you interacted with older people, you'll more likely see the older lady in this picture, not the younger lady. Okay. Now, if you've interacted with both, you're more likely to make that visual adjustment between the old lady and the young lady. Okay. And if you want to try and figure this out, if you haven't, this, let me, The big adjustment is this area right here is the jaw of the young lady, but it is the nose of the old lady. And down here is the chin or the jaw of the older lady. So for those who weren't sure, maybe you could see it that way. But the idea is that we see things as a whole, and when there's something ambiguous, we then use experience to determine what it is that we're actually seeing, okay? One of the rules of Gestalt is how many triangles do you see in this image? Let's see, how many triangles does everybody see in this image? Four, five, five, five. All right. If we were in geometry, you'd all fail. There's actually no triangles. There are 1, 2, 3, 4, 5, 6 right angles, but there are actually no triangles. But what does our perception system do? One, first of all, you'll notice that there's almost this imaginary line right here that then makes this seem brighter than this, but it's not. This is the same brightness, okay? And then the law of closure also tries to close off some of these guys. And you'll notice that there's even more difference between this and this versus this and this, okay? So all of you are going, oh, you just tricked us. But what I want you to see is this tendency, if you'll notice that it seems like these two whitenesses are different, that this bigger one seems brighter than the exterior of them, okay? And this is called the law of closure, okay? And we'll see this in some visual illusions a little bit later. Some other rules of this is that we tend to group things that are similar to each other. So even though these are a distance from these, we tend to put all the black triangles with the black triangles and all the whites with the white triangles. This is not a racial thing, by the way. This is just a visual thing. Proximity, we tend to group objects that are closer together. The law of continuity, even though these can be very random lines, we make something out of this, right? That we feel like that there's some type of image right there that we should be paying attention to, and these are largely ignored, okay? Symmetry, human beings love symmetry, okay? If we have time, we'll get into laws of attraction, and we'll actually see that people, the more symmetrical a face is, the more attractive a person is rated, okay? And so in those experiments, what we'll see is there's a individual where his face is naturally not symmetrical. But then using computers, they make basically the left face mirror the right face. And so it's perfectly symmetrical, and you could guess that the mirrored face is rated as highly more attractive than the non-mirrored face, okay? Humans love symmetry, but I'll get into why that may be later on. But this is just one of the laws. And then the laws of periodicity. So one thing that if we were to measure this is really the distance between each of these outer dots isn't much difference than the distance from the center dots to them, okay? And from these to these, but you'll notice that we try to complete these figure eights, even though all the dots pretty much randomly are close together, the same distance, okay? So these are kind of some of the ways that we organize information. Um, okay, let me go into some of the visual system. It's one of the systems that is most studied. And so it is kind of interesting to get to. You don't need to memorize any of these terms, but the thing that I do want to focus on is some examples of what I've been talking about. So right here where the optic nerves, all these nerves are leaving into the optic cavity, there is no sensory receptors right here, okay? And that's so right here, we actually have a natural blind spot. Okay, there's no way that the eye is creating the complete visual picture that we see. Okay, in this area, in the retina, is where our nerve cells set. Okay, and I think, do we have these defined? All right. We do have these defined. This is where all our cones and rods, these are the two types of sensory cells, which we'll get to here in just a minute, okay? Just like the rest of the body, the left hemisphere of your brain controls the right side of your body, and the right hemisphere of your brain controls the left side of your body. And this is the same with vision, okay? Stuff on the right visual field are going to go into the left occipital area, and the left visual field will go into the right visual area, okay? And then they're transmitted to the back, okay? Now, there is some things that I do want to emphasize on this. It is where these two areas cross right here that inverts the image, all right? The image stops in our limbic system before our occipital lobes even see it, okay? Meaning that our brain basically, and this goes back to Freudian unconscious psychology, our brain is already processing visual information before we have a conscious reality of it, okay? What this is doing in this limbic system is it's preparing us for our emotional reaction to what we're seeing. Yes, we laugh before we see something that we're supposed to be laughing at. It prepares us for fight or flight. So if we're again, before we get in a car wreck, we're usually avoiding that car wreck before we actually realize that we're about to get into one. I bring up the example where if we're really angry with someone, we're preparing to aggress towards them, and then it goes to the higher area of the brains, which then say, no, knock it off. So my point being in this is that there's a lot of things that are happening on an unconscious level before we even have a visual reality of it, okay? And this becomes important in the next section when we start talking about emotions and motivation. Okay, and so I kind of want to leave that as a cliffhanger for right now. So just to kind of give some things, I want to go back to some of the things about the light. So the stimulus, of course, is light. The intensity of light is based on the wave, okay? Shorter distant waves are more highly intense. But the thing that I do want to focus on is this. So the retina is where all the rods and cones are located, okay? And if we were to draw a retina as a circle, the center of the retina is where the majority of the cones are, okay? And at the periphery of the retina is where all the rods are located, okay? When we say shaped 3D, we're also talking about black and white. This gives us our hue, as you would say it, okay? And so color is something that is deeply processed by human beings, and then black and white are next. This is why some early studies of dogs assumed that dogs could only see in black and whites and shades of black and whites, because top dogs, unlike humans, tend to have more rods than cones. I will tell you that theory has been debunked. They see more contrast, but they do have a range of color that they can see. Um, Not the wide range humans have, but they have a range of colors that they also can see. So the dogs don't actually see black and white or shades of black and white grayness. They actually can see some levels of colors, but they are able to do better contrasts than we can do, because that's what our rods provide us. Okay. If you want to see an example of these two systems, if you're going to the bathroom in the middle of the night and there's no lights, usually we try to intensely look in front of us, but that's trying to use the color system, okay? Instead, when you walk to the bathroom tonight and there's no lights on, look in your periphery, not right in front of you. And you'll notice that the room will actually light up, because what you're using when you're looking out towards your periphery is not your cones, but you're using your rods, which are sensitive to intensity of light. Okay, kind of when I learned this, I'm like, wow, I can actually make it to the bathroom without stubbing my toe. Try it and report back to me what you find. Okay. Go through. What do I want to talk about next with this? Okay. My issue with going into this next section in theories of visual systems is that they're actually kind of currently changing. The traditional models, we traditionally use two traditional models: the trichromatic theory, which says that our cones are sensitive to three different lights, the three primary colors. And if we don't have one of them, then we can be colorblind. So if we don't have the cones that make green, instead our eyes will fill it in with this orange. So if you have the green color blindness, what you would see is orange. But you wouldn't be able to see this. I think it's a letter 8 right here, I believe is what it is, right there. So, and this was color blindness was one of the ways that we first started to understand cones, and we found that people are colorblind to three basic colors, which are the three primary colors. Okay. However, while I do, we can look at color blindness as a good example of this. I do want to let you all know, because we are early on in our career in psychology and in your education, this theory is rapidly changing. The three primary colors are probably not the three cones that we have. And right now, there's a lot of research that suggests that there might be 4 types of cones or 6 types of cones. So, but this is one of the early theories based on color blindness. Okay. The other theory that then kind of complements it is what's called the component processing theory, which says that we have cones that sit by each other. So cones that are red sit by cones that are green. And when there's more red, we see more red. When there's more green, we see more green. And this is done, and this has never worked in a Canvas class, so I'm just going to kind of explain this. You probably have done this before, but if we were in a dark classroom and I had you say, I want you to just focus on this little black dot Now it's red in the middle of the screen, okay? And then just focus on it, and I gave you 15, 20 seconds, and then I changed it to this and asked what you saw, what you see now. Normally, the person who saw this blue will become yellow, and this red will become green, and this green will become red, okay? Because what is happening, according to this theory, is that we were focusing on this, and we burnt out those cones that were focusing on this original image. And then when I switched it to just a blank one, and I said, you should still be seeing something there, the brain starts igniting the sensory cells that are just right next to it, which is the opposite of the ones that are there. So the cones that sit next to yellow are blue. And so the brain turns those on and say, this is what you're seeing, okay? This is why if you look at the sun for too long, you see black spots in the afterwards, because those cells were burnt out, because all of the colors of the rainbow are basically hitting your eyes when you look directly at the sun. This is why we see after images and those types of things. Okay. I want to go into just a little bit about depth perception, okay? And when we look at depth perception, we can look at it in two ways. We can look at it from a monocular view, meaning that we're not looking at it from a perspective of depth, but we're looking at it from cues. And then we can conclude for tonight, okay? So when we're looking at things in the 2D, we try to make 3D sense of it. And this can be seen in some visual illusions that we'll go through right now. So in this example, we have line A and B, and we ask participants, which line is longer, which line is shorter? And if you're just looking at this from a visual cue, usually people will say that line A is longer and line B is shorter. But if we measure them, they're actually exactly the same length, okay, this primary line, all right? This is an illusion that a lot of fashion people use, all right? So for example, if you want to make someone feel thinner because of their clothing, you do the stitching inward in the clothing, okay? If you want to make a person who's maybe really small feel larger, you do the stitching towards the outside instead of the inside, all right? And this way it provides this illusion that that you feel thinner or you feel wider, as you would say, okay? So this is an example how this illusion is used in different marketing areas, as you would say. This line, again, what are we trying to do with this is there is no natural horizon line. I will tell you first, the length of this line is the same length as this line. Some of you may see it, but most people see this line as longer than this line. But if we laid them right next to each other, they're actually the same length. But we're perceiving this one as longer because we're trying to find its horizon. And this is important as one of our main illusions. This is another illusion that as we see, this is getting closer and these lines are getting closer. These two lines right here are exactly the same length. So if we put them next to each other, they're exactly the same. But we're using these visual cues to kind of tell what they are. And then, of course, there's this one. But I'm going to end this idea of sensations and perceptions And the reason why I'm using more of these literal examples, because we can see them, right? They're visual. But throughout this class, we're going to see that a lot of times we construct our world and the way we see our world, not necessarily based on the way the world is, but in the way we have constructed it in our mind. And these two visual examples are probably the best that I can think of to kind of end a conversation like this. Is if you have ever looked at the sun, the sunrise and the sunset, and you see the huge sun and it's setting and it looks huge and humongous. But then when you looked at it in the middle of the day, up in the sky, it looks small, okay? But then remember when have your camera at that sunset and you're like, I want to take the picture of the perfect sunset, and you take a picture of it and the sun is really small. It's tiny. It's not what you see. And then you have to tell your friends, I saw a beautiful sunset. This picture does not do it justice. All right. There's some illusions that are going on in this. One, we don't see the sunset for how it actually physically is. We see the sunset for how our brain has constructed it because it's at a high line. It has reference points of where it's at. Technically, and scientifically and measurement wise, the sun is furthest away from us at the sunrise and the sunset. It is closest to us at noon, at the middle of day. That's when the sun is actually closest to us. So if our perception was a one-on-one association with our sensations, the sun should look bigger in the middle of the day than when it's at the sunrise and the sunset. Okay. And I'm going to end this because I'm hoping that I brought up some philosophical and things to think about as you start to really think about how you interpret the world and how you think about it. Because doing this sensation and perception section, I'll tell you, when I did this in Psych 101, and my mind was blown, because I was like, wow, I really need to rethink about the way I see the world, and that maybe other people can see it differently than I do. And if this is happening physically, and I think that I have the objective reality, but I really don't, I really need to rethink things. The other point that I do want to just end with, this is going to be on a funny note, and then you're off to your spring break because we're out of time. Our olfactory system, I'm going to tell you why I do not chew gum in a bathroom. Okay. Our olfactory system, our smell system, is a chemical system. When chemicals go into our nose, they hit receptors that then give us our perception of whatever we're smelling. Okay. So when we're in the bathroom and we're chewing gum, all of those chemicals in the bathroom are going into that gum. So if you have people in there that are farting, or you can smell that, those are chemicals that are going into your gum, that then when you're leaving the bathroom, you're chewing with you for the rest of the time you're enjoying that gum. So with that being said, I would encourage you to stop chewing gum in bathrooms if you do, so you stop chewing people's farts. With that said, is there